So today's lesson is on weight. So to start with, I would like you to label our astronaut Felix with the forces acting on him and also label what their Newton's third law force pairs are. So pause the video while you do that. Right, you should have labelled weight acting on Felix. There's no air resistance acting on him because he's in space. So only the force of weight acting on him, pulling him down. And then we've also got the third law force pair from that is the Earth being pulled up by Felix's gravity. Okay, so remember with equal and opposite reactions, it's the same type of force but on the opposite object in the opposite direction. So the force of the Earth pulling Felix down is countered by the force of Felix pulling the Earth up. Right, so what is weight? Weight is defined as the force due to gravity acting on a body, and that will change in different gravitational fields. So you go to a different planet, you'll have a different weight. Mass is the amount of matter in your body, and that's due to the number of particles in your body. If you go to a different planet, your mass won't change, your weight will. Weight is calculated using the equation weight equals mass times gravitational field strength. Weight is measured in newtons, mass in kilograms, and gravitational field strength either in newtons per kilogram or meters per second squared. Either of those units is correct. On Earth, the value of the gravitational field strength is 9.8 newtons per kilogram or meters per second squared. And the reason we have two units is because g can also be described as the acceleration due to gravity. If you go to a smaller planet, then the value of g is going to be lower. And if you go to a bigger planet, say Jupiter, you're going to have a much larger value of g. And that's why your weight would be more on Jupiter than it would be, say, on Mercury. We measure weight with a device called a spring balance. Okay? The other name for spring balance is a Newton meter, because weight is a force. Okay, so I've done this little table to compare mass and weight. So what is it? Mass is the amount of matter in an object, whilst weight is the force of gravity acting on the object. Mass is measured in kilograms, and weight is measured in newtons. Mass is measured with a balance, and weight is measured with a spring balance or Newton meter. Now, what is really, really important is that you don't say that either mass or weight is measured with scales. Okay, that's not the proper scientific term. You need to use balance for mass or spring balance or Newton meter when you're talking about weight. Okay, so the next thing you need to know about is the centre of mass. And we say that the weight of an object is acting from the point called its centre of mass. And if we want to find the centre of mass of a symmetrical object, what we do is we find where the lines of symmetry cross, and that point is the centre of mass. That's nice and easy. If we wanted to define centre of mass, we would say that the centre of mass is the point at which the mass of an object can be considered to be concentrated. Okay, and the considered bit is really, really important because it's not the point at which the mass is concentrated. My mass is spread all through my body. It's not concentrated at a single point. But for doing, making predictions about how my body behaves, if I'm falling, for example, we can imagine that I'm just a point. And all the calculations are much, much easier that way. So that's why we use the idea of centre of mass. But you can't say it's the point at which the mass of an object is concentrated, because that's not right. It's the point at which it can be considered to be concentrated. I like to remember it by thinking about a ring donut. I like to think about ring donuts, but not as much as I like to eat them. So if you find the point where the lines of symmetry cross on a ring donut, you will find that that's in the middle of the hole. So the centre of mass of a ring donut is where there is actually no mass at all. So that's why it's where it can be considered to be concentrated. Okay, let's do a little true or false. You need to try and answer the question before the answer comes up. So weight is measured in kilograms. That's false, of course. Weight is measured in newtons. G is a constant. Also false, it's only a constant on Earth. It changes on different planets. We measure weight using a spring balance. That one's true. W equals mg is the same as F equals ma, but for a specific case. That one's true. Okay, so weight is a type of force, so W and F are interchangeable, and G can also be called the acceleration due to gravity, so that could be replaced with that A. Okay, the weight of a bag of flour is 2 kilograms. Is of course false. The mass would be 2 kilograms, the weight would be something in newtons. Okay, have a go at the questions on Fronter.